All right, so we just reviewed the fact that a linear function has a constant rate of change. So, same one from yesterday. So linear has a constant rate of change. And if we looked at a table, what would that look like? It would look like something like this. We'd have our x's, we'd have our y's, and this is a linear example. So as x changed by 1 unit, there'd be a constant change in our y's. So let's say it started with 7, and then it went to 11, and then 15, and then 19, and then 23. Hold on. Okay, so what is 11 minus 7? 4. What is 15 minus 11? 4. What is 19 minus 15? 4. And 23 minus 19 is also 4. So that first difference is constant. It's the same thing when we have a linear function. That was linear. So we studied that in 8th grade and in 9th grade. And then in 9th grade, we also added on there exponential. So with exponential, instead of adding the same amount every time, it started getting multiplied, didn't it? Okay, so let's say our first number was 5, and our next number was 10, and our next number is 20, and our next number is 40. Right. So it's not a difference this time. We have a common multiple. Times 2. Times 2. Times 2. You know what that tells me? That base of that equation is going to be 2. Yeah, that's what that tells me. Okay, so these two we've already studied. So now we're going to add to that quadratic. Now, quadratic doesn't have a common first difference like linear, but we're going to look and see what is common. So here's our first example of a quadratic. So our x's are all increasing by the same amount. Do you see that? Up 1, up 1, up 1, up 1.
Yeah.
Okay, so let's look at this difference. Isn't this difference down 3? Or if we did 1 minus 4, do we get negative 3? Okay. Is this difference down 1? Is 0 minus 1 negative 1? Okay. Is this difference 1 minus 0 positive 1? And this difference is 4 minus 1, which is positive 3. Okay. Those numbers are not the same, are they?
No.
So this is not linear. It is not linear because we do not have a constant rate of change. Can I multiply by anything to get to the next number? No. So it's not exponential. But with a quadratic, which is what this one is, let's watch what happens here. What is negative 1 minus negative 3?
Positive 2.
Positive 2. What is 1 minus negative 1? Positive 2. What is 3 minus 1? 2. Do you see that the second difference is the same? So, with a quadratic, we're going to have a second difference that is constant. A second difference that is constant. And if I graph this, let's throw a graph. That's not a graph. All right, we'll leave it there. Okay, let me go back in and change it to a graph now. Where's my graph stamp? All right, I got to move homeboy for a second.
No, you're not moving homeboy.
I'm just gonna, I got to move it. We'll put him right up there by second difference. Okay. So if I were to graph this, 0, 4, 1, 1, 2, 0, 3, 1, 4, 4. Does that look like a quadratic? It does. Do you see it now? And I bet you could write the equation for this looking at it. Where's the vertex?
X minus
0,
2.
The vertex is at
2, 0.
2, 0. So it would be y equals x minus 2 squared plus 0. Do we need the plus 0? No. There we go. Okay. All right. So now let's look at the next one. We're going to come back to this part 2 in a second. We're not going to do it yet, though. Okay. Let's look at example 2. All right. What I want you to do, every time I want you to check and see, do the x's increase by the same amount? Yes. Now, let's look at the y's. If I did -2 minus -3, what does that equal? 1. Okay? 1 minus -2. What does that equal? 3. So we know it's not linear because we got something different. If it was linear, these first differences would all match. So I can already rule out linear. It is not a line. Okay, now let's do 6 minus 1.
5.
That is 5. Okay, now let's do 13 minus 6. 7. Okay, so, and we can also tell we're not multiplying by the same thing every time. If we're multiplying by the same thing, exponential. So we ruled out linear. We ruled out exponential. Let's see if the second difference is constant. I'm going to write in green since it's St. Patty's Day. So for the second difference, we do the difference in these numbers. The second difference. So what is 3 minus 1? 2. What is 5 minus 3? 2. What is 7 minus 5? 2. Did I get the same thing? And when the second difference is constant, when that second difference is constant, and what do I mean by constant, guys?
It's the same.
Good. Good. And I'm going to put that out by the side because I like the way you defined it.
You need to put homeboy back up there.
Okay? Then we have a quadratic function. Okay, so if your teacher asks you what kind of function this is, you would say quadratic. And if your teacher asks you why, how would you defend why? What would you say?
Because the second difference is constant.
That's exactly what you'd say.
Chris Nevins deserves a pizza.
He's getting some candy. Oh yeah, come get it.
I was just jealous.
Chocolate smorgasbord right here. You can't take the whole basket. Pick out two. Okay. Alright. So, I want you to try number 3. You try number 3. Let's see what you can do. And if you're not sure what to do, right now I'd like you to please ask me. Yes, ma'am. Yes, ma'am. Okay, What's my next two? 4 and what's 4?
You just take one, you got one more. Take these two and just
You good, Leo? Grown child.
I turned in that big paper, but I had turned it in
No, I did. I got to do the words. Yeah. Jack, if I can borrow theirs. Underneath the class. Oh! If I'm sure of that. Kill yourself. Please. Jump off a bridge.
Okay.
Slowly growing up having this class. Now you just.
Alright, so in this one, we get -7, -3, 1, and 5. And then when we subtract these two, we get +4, +4, +4. They're all the same. Is it a quadratic?
Yeah.
Okay, now, today, your teacher, every single one of them is not going to always work. They're going to give you some that work and some that don't. I just gave you examples that worked. Now, there's one more step we can do with this that is really cool, and your teachers are going to show it to you. But the best part for you guys is you're not going to be responsible for this part on your test. I will probably make it a bonus. It wouldn't surprise me if your teachers did the same thing. So, let's talk about, since we now know that example 1 is a quadratic function, can we come up with the equation for it?
Yes.
And we can, if we follow these steps. Step 1 says to plug the y-intercept into standard form. Do you guys see that this right here, 0, 4, is the y-intercept? What is C in your standard form? Isn't that the y-intercept?
Yes.
Okay, so because, girls, y'all want to listen to this. This is not intuitive. All right, because they give us C, we can plug that in. So now we know y equals, or f of x equals, ax squared plus bx plus, instead of c, what do we know c is? 4. Okay. Step 2 says now choose 2 other points and plug them into step 1 to create a system. Alright, so I'm going to choose this point. I'm choosing that point, and then I'm going to choose this point. And it doesn't matter which ones I choose. I just randomly pick those. So now, is this an x and this a y?
Yes.
Okay, so I can plug 1 in for x, and I can plug 1 in for y. So I get 1 equals a times 1 squared plus b times 1 plus 4. So I plugged in 1 for x, and I plugged in 1 for y. Now I'm going to do a second equation where I do my next point. But this time, what am I plugging in for x?
2.
2, and what am I plugging in for y?
0.
0. So I get 0 equals a times 2 squared plus b times 2 plus 4. Okay. That's kind of ugly looking, so I'm going to simplify it a little bit. This right here, this becomes 1 equals, what is 1 squared? 1, so that's 1a plus 1 times b is 1b plus 4. Can I move the 4 to the other side?
Yeah.
Yeah. So minus 4, minus 4.
Negative.
What would that make that over there?
Negative.
-3. Okay, so this becomes -3 equals 1a plus 1b. Let's do the blue one now. This is 0 equals, what is 2 squared?
4.
4a plus, this makes 2b plus 4. What happens when I move that 4 to the other side?
Stays at 4.
It becomes
Negative.
-4. So this one becomes -4 equals 4a plus 2b. Do you guys remember, and probably not, probably going to have a little cobwebs on this one, elimination to solve a system?
Yeah.
Yeah? Okay. If you don't, that's okay. I'm going to show it to you. If I want the b to go away,
You have 2 equals.
I'd want this to become the opposite of this. Right now, this blue b is a positive 2.
-1.
So I would have to multiply through by -2 to make it the opposite, right? I'd have to multiply through by -2. And when I do, this would become +6 on this side. The -2 gets multiplied all the way through. So it becomes -2a and -2b. This was called elimination. Because what did we just do to the b's? We eliminated the b. They're going to cancel out now.
Just leave it
And this
2A.
gives me 2a equals 2.
Divide
So what is a?
2.
When we divide by 2, a is 1. 2 divided by 2 is 1.
Same thing for
Okay. So we know C is 4. We know A is 1. What's the only thing we're missing?
B.
B. Okay? Let's plug A back into this one. And we get -3. What is 1 times 1? 1 plus B. So when we subtract 1, what is B?
-4.
-4. So now I have A, I have B, and I have C. So it's y equals ax squared bx plus c. There's my equation. Now, you do not have to do that on your test. But some of your teachers are going to show you that, and I wanted you to see it in here first. Okay, leave your notes out, because if you have good notes today, you get a piece of candy.
Where? On the notebooks or on the paper?
Wherever you took your notes.